Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about why did Stadia fail. So let's dive right into it. Now, one thing you must know, whenever we are talking about a project of this magnitude, of this scale, there will be multiple things that would have led to its failure. And if you ask 10 people, you will find 10 different answers, and that's the whole point of it. So you can analyze, like, okay, according from, like, let's say visual point of view, artist point of view, what went wrong, from an economics point of view, what went wrong. Like, there will always be a different answer. So what was it, this Stadia thing? It was a Google product that was launched in November 2019, so not very long ago. And the dream was, the selling point of it was that gaming would be just as easy as watching YouTube video, meaning this video itself. You could be watching in your desktop, you could be watching in your mobile phone, you can be watching in tablet, even in your bathroom, in your mobile phones, whatever have you. It's easy. So they wanted to make gaming as easy as that, and your performance will not degrade based on the size of your equipment, meaning if you have a giant ass, big ass gaming computer, you're gonna have kick-ass performance, and the moment you go to mobile phone it becomes like blah. That will not happen. So fundamentally, they're gonna give you same performance and same convenience of YouTube. You just get a console remote, basically controller, and that's it. Like, you can play the latest and greatest game in your laptop, you can play latest and greatest game in tablet, mobile phone, whatever have you. You do not have to think about it. It would be just as convenient as YouTube. And what will you need for this quote unquote convenience? You have to have good internet, and you have to have subscription of the Google Stadia thing. And Stadia was axed. This puppy was ended in September 2022. Now be mindful, the servers are still active. They will take time to shut down properly, and that time is scheduled for like 1 year from now. So that's what happened. Now, why the heck, this shutdown? Well, reality was, like, if you calmly look at it, there was no unique selling proposition into this, meaning there was no actual reason to go into Stadia. While the convenience is a thing, but convenience itself may not be enough. And again, Google Stadia does prove that it was not enough. So what the hell happened? Well, you have to understand that there is internet. It runs on things. That things are generally photons. Now, photons are super fast because, again, they are photon. They are traveling at light speed. But we do not have photons from server to your home. Even if, like, for example, myself, I have a photon basic based system. I have fiber to my home, but problem is that fiber literally is connected to mobile tower. That mobile tower would convert that photon into electron, then convert it again into photon in different spectrum, different color, and then send it to different fiber links. Then that will go to exchange. That exchange will do the same thing, again send it to somewhere else. Then it will go to undersea fiber cable again. At that point, it will be directly crossing the sea, photon only. Then it will do the same thing again and again. So every stage where you are going from photon to electron to photon, again, this conversion stage is adding latency. And if you are connecting internationally, you could have way too many latency steps. Even if you are connecting inside a nation, you may have like multiple hops that will add latency, and nothing can be done about that. That's a law of physics. And even if you just have direct photon lines, which meaning generally, what's the difference between residential connection and business connection? Business connection have like fewer hops, like they are specifically tailored made for that. That's why they do not have like magical speed or magical bandwidth or something like that, but they generally have very low latency for that reason. The hops, they are specific. Like, many times they will directly give you a hard line to exchange, so your latency is even less. So that there is a physical limitation how good your internet can be, and specifically with distance, meaning every time zone you have to have a server there. You cannot play a game like USA is divided in three time zones, so it would need 3 server clusters. India would also need 1 server cluster. China would need 2 server clusters. Australia would need 3 server clusters. You get that point? Like, you would need server clusters to manage it. So Google did a survey, and the survey showed that yes, people had a lot of bandwidth, meaning to send data. Back in the old days, like, we have been doing multiplayer online gaming for long enough, but the only thing that happened back then was basically both of them, basically player A and player B, or player how many, player 20, let's say, all of them have game running on their system, and all that has been synced between them is just data. Now, what is that data? Because again, video is a data, but you have to understand, character model that you see in a game, like me doing like this, it would be generally done by mesh, would be in the computer, but the bone structure, basically, that is animating the system, that data would be transmitted from A to B. So if you move your character, so character moving animation and all that coordinate system, that's will be transmitted to every other. Basically, it would be broadcasted, hey, player number 5 moved in this location. That would be transmitted to everything else, and all other computer will render it on their end. They will not port a camera there. They will just render the data, and that vertex rotation data is all that transmitted. That's why even on very low bandwidth, we could do multiplayer gaming back in the old days. But nowadays we have bandwidth where you can actually have video stream going from A to B, server to computer. And again, YouTube proves that and Netflix proves that. However, while that part is true that we have bandwidth, heck, I even have a mildly good connection where it's like 300 Mbps. So it's good. So we can do a lot in terms of bandwidth, but in terms of latency, not that much. My latency is not that great. And again, it's for almost everything, it's more than GG. But the moment you to go about gaming, that's not good enough. And again, I may be the exception part of here. So fundamentally, what does that mean? That physical law, physical limitation, that means you cannot go into high frame per second. Fundamentally, you can. You can send the data, you can send 120 frame per second, but it will be horrifyingly lagged. It will literally feel like there is a latency addition added to there. There is no point there because feedback loop will, like as you can see, it takes time. Like you can feel it. Like I press the space bar, it takes time. And if you are registering it that easily, professional player will be like, dude, no, just no. So there is no point sending higher frame rate per second. So practically only 30 FPS can be done, 60 if you are pushing it, 120, yeah, you can send the data. Like this TV can render it. Many TV nowadays can do 120 FPS, but there is no point of doing it. Because again, latency will literally fundamentally make many frames would be just horrifyingly lagged. So 30 is easy. Now you may like 30 is too low. Not really. Majority of console games are still at 30, and many of modern console games, they have ray tracing option. The moment you turn it on, it will go from 60 FPS to 30 FPS. So 30 FPS is more than good enough. Be mindful, we still watch movies that are 24 FPS. More than good enough. If you have a really good, smooth experience of 30 FPS, you're good, you're solid. And a 60, really good. But practically 30 is the best that they can aim for. Now, what Google was doing at the end of the day, it was just literally trying to sell you an idea that you have like software development kits or basically game development kits on a remote end. Basically this was in the server and you were just connected to that. Like I had experience with this system because I worked in Forza, and we had this, and in our studio this was connected to the main network and multiple people, because like for example, I was working on some assets that are going in road signs, somebody would be working on vehicles, somebody would be working on road. So all of that data would be collaborated here, so multiple player can access it. It literally feels like that. What Stadia feels is literally a virtual instance of this is running in the servers and you are accessing it. That's all it felt. It's just a server that is on the cloud. That's it. Like it did not feel different. It was just like, okay, a console with one extra layer of internet behind it. And that created a problem. While it did work, it was a system, it did work, it did not have a true USP. It was just like convenience. Now convenience is good enough, but again, convenience many times may not be good enough. You have to add something extra. For example, Steam gaming system, it became such a big deal. It was convenient, yes, that was good, but again, it also had Steam sales. Those boosted each other, and then voila, you had that. So having convenience as unique selling point is a good thing, but only convenience, that may not be good enough, and that's the problem. So what they had should have done is basically ported a game engine for their servers, and I'll explain that part. Like basically they had this and all the output was like low end things. It's like, why? And I'll explain that part in 3 core segments. Segment number 1, graphics. Now because I am a 3D game artist and this is what I used to do, you have to understand all the games. You may think like they're running on latest and greatest hardware, they are running on the latest and greatest software. No, just no. Like you would be shocked how outdated these things are. Like you would be shocked. That's my criteria. Like I worked on like basically Spider-Man before it came out, the Spider-Man reboot on Sony PlayStations, and it was like, why the heck they're using this structure of like a mesh model and like shader and all that. Like they were not even using physics-based rendering. I'm like, why the heck PBR was like so common that we are using in Marmoset for making our portfolio? Why the heck it was not there? Game engines had that. It's just that when you see the game, like when we are working on a game, that game has already been there, processed, planned out, figured out, license signed, NDA signed, all that could have easily taken 1 to 2 years. So by default, it's already 2 years behind. And generally, game companies always want to make sure their game works rather than giving you latest and greatest and be like, okay, it actually does not work. Most companies cannot afford that. Like, a game, yeah, it's forever delayed game, or like, Cyberpunk, where there's like, dude, the game just broke. Like, so fundamentally, games are fundamentally very behind schedule, like in terms of latest and greatest technology. Another aspect is they're always scaled back in terms of their horsepower. They're always scaled back for lowest common denominator, and it's generally the console. Now you may be like, wouldn't console be the latest and greatest? No, they are always fundamentally behind schedule, because here's the deal. How do you think PS6 would be made? once PS5 is made, sold, sorted, like they will make Mark 1, Mark 2, sort everything out, figure out all the driver configuration, then they will start on Mark 6, basically, PlayStation 6. They will go to AMD. They're like, bro, we want this. Okay. AMD will ask how many units you are expecting to sell, like how many, at least in batch one. So they'll say, okay, 1 million. Okay, cool, awesome. What is your development timeline? They say 2 years. That fundamentally means AMD will pick out something that is they have already built. Then they will custom build it for Sony with their instructions, with their limitations, with their budgeting and all that. Just they will sort that out. So they will always pick one generation behind or the generation that is already out. They will never be like, okay, this is the generation that's going to come out in the next. They will always be back because they have to redo it. And they do not have the luxury of motherboard manufacturers. They do not have the luxury of like other RAM manufacturers and all that. So that thing that allows you to like have a different GPU, have different RAM, have different motherboard manufacturers, have different SSD providers, that solves so many headache for CPU manufacturing. That's why CPUs are getting, exponentially upgraded. While your console is one package deal, it's almost like system on chip. So AMD has to sit down and they cannot risk it like, okay, we're going to try a new system because it could delay the, launch, and Sony will not accept it. So they're like, okay, we'll take the old system. Of course, so they will refine it, fine tune it, and they have found, let's say, some foundry upgrades that they're like, this architecture is awesome, but if we can just take it from, let's say, 5 nanometers and put it to 4 nanometer, it will make it more energy efficient. They will do those sort of things, but they will not redesign everything. They do that. They are already behind schedule. It will take at least 1 to 2 years before they will spin up even a single physical silicon. Then it will take time for validation and final confirmation, and then it will take time to develop the software kit. Like when PlayStation 3 was released, the processor in that puppy was actually good, ahead of the pack, so to say. But you can see PlayStation 3, when they released the first games that were launched for it, it looked almost like PS2. Why? Software development kit was not ready. It took years, and by the time you can actually utilize that horsepower, PC caught up and beat it. And that will again happen this time also. And nowadays it's not even happening. At this point, it's like you are at least 1 or 2 generations behind. Like I did not pay attention to it, but now I notice the games are like, most of the games are running at 30 FPS. I'm like, that's why, like, fundamentally they are always behind schedule. And even if you are like, okay, what about a game that is only built for PC? Like, let's say there are some Steam studios that are only focusing on making a game for computer. They will still focus on low-end CPUs, because again, you cannot have this game is amazing, but you have to have a RTX 30 series card. Nobody's gonna buy it. You have to be like, even if you design it for RTX, you have to tone it back so it can work on GTX series, like at least as back as 900 series. So fundamentally, that was like biggest shocking event. Like, hey, dude, I can make so high poly mesh. I can do this. I can have normal maps and all that. The game engine is like, the department that was dealing with that is like, bro, tone it down. It's like, why? We can handle it. It's like, no, we can't. Like, I'm thinking like, oh, we have 8 GB of RAM. They're like, no, design it so it can run in 2 GB. That's the whole point. And because Stadia games were not ported for servers, they were like still console games. So they could have just started on the next level. And there is another aspect of it. PC hardware is one generation behind the server hardware, meaning what servers tool that Google Stadia had access to. Basically, they had access to DDR5 and PCI 5.0 before we got it. So they could have literally went to basically Unreal. It's like, bro, port a engine for us and throw away all the optimization script that is for the low end equipment, make it high end. Just like throw everything away. Throw 10,000 LOD layers. Just throw that away. Just make everything, because again, inherently you don't even need to worry about like direct storage. You can literally undump a file into server RAMs, because server RAMs are as huge as 2 terabyte or 4 terabyte, and you do not even need, oh, every blade has to have that. No, one core server will have that, and then it will render out the frames, basically render out the vertex, and the final rendering rasterization will be done by basically GPU units that will be connected to the customer. So main core, blades that are rendering the camera view, point of view, and the main game is happening in the server. That could be amazing thing can have been done. So we would imagine a game world where you do not have LODs. It will look completely different. You're like, what about these games and all that? Trust me, as a game artist, the moment I look at, that's how you're optimizing it. That's why all your dustbin looks exactly the same. Pay attention to the small assets. That's the easiest way you can figure out where they are optimizing. It's like, bro, like, and curves. Curves are the easiest way. You can notice polygons, that means they optimized it. Again, I don't blame them. Again, as an artist, we had to do that. That was we were getting paid for. It's like, make it optimum. So they could have, Stadia could have literally created, even ported an old game, or old as in like that game has have full service file ready. They could have redone all the high poly assets, made into game ready assets, and voila, the game would have looked exponentially better. Things that you and I cannot even think about, it would have looked so much better, because if it was designed for highest potential thing rather than lowest common denominator, it would have a whole different level. Like, trust me, I am unable to convey the majesty that you would have seen. Almost like how back in the days when you had, like, cutscene that was rendered, and then you play the game, it's like, what the hell happened? Same thing. A world without LODs and calls. Every time you see a frame rate drop, there was a call. Basically, your CPU made a call, GPU made a call. It's like, hey, I need this file, or I need this, or it got stuck rendering some particle effects. Particle effects are brutal. So all those sort of things, if it was designed from like Unreal to server, it would have been like glorious. And it would not have been expensive, because what is expensive in game engine is making it optimum. It's not, it's like, it's completely different ballgame. It's like, hey, do you can flex it? Oh yeah, flex it to 2 terabyte, easy, go ahead. It's easy. Then we come to the interaction part of it. It actually affects the gameplay. Now, you must have noticed that there is no real-time physics in multiplayer specifically. Is that even though we could have done this long ago, like these are old systems, we could actually do this. Like that's why Crisis 1 was so kind of groundbreaking. Like, you can actually take sheds and actually destroy them. It was like, whoa, we have been doing that for so long. Then why the hell it's not a thing in majority of the games? Like, you can play God of War and like it's a good game, but try destroying anything. Like, it's not possible. It's not that the game developers did not want it or artists did not want it. It's like they could not do it. Console was the limiting factor. And in multiplayer, this simply cannot go, because again, as the all you are transmitting is vector data. It's like, hey, point A, XYZ coordinates, point B, XYZ rotation. That's all you are transferring from A to B. And if you have to resend all the data, let's say a physics body happened, you cause a distraction, all this vector data has to be transmitted amongst, let's say, 150 players. Yeah, no. So the only way this can be done, which I saw a very long older demo, I could not able to find it again. It was like E3 of like 2009 or something like that. They had a server, as I specified, like you had a core server that was rendering everything, rendering as in like doing all the gaming work. And then they had small units that were like, if you have 10 players, you'll have 10 small units that are rendering the files for them, basically rendering what the player sees. And they had water body physics, and they had like birds as a player and a simulation. Like, it has effects that fundamentally cannot be done. It can only be done in movies. They were doing it in real time back in the day, because again, game engine working for your PC, your console is different compared to a game engine that could be designed to be like, bro, relax, let your wings out. It would be completely different. That is back in the day that I saw. Like, imagine this sort of thing where you can actually, let's say there is a multiplayer map and you can actually destroy the map. Imagine like everybody is like, if your team is like actually planning it, they're like, let's all throw all the grenades here, and if the building actually collapses. Nowadays, you can't do that. All you have is like scripted events. It's like, okay, this wall you can punch hole. This one, why can't you punch hole? No, the again, computer cannot handle it. And again, if it was a real time event, it will look amazing. It will feel dynamic. It's like, yeah, you can have C4s, you can have tanks and all that, but try destroying any building in Battlefield 4. You can't. Interaction is fundamental. And let's not even go into collisions. And collisions are another aspect of it. Collisions are like, because again, collisions do not have LODs. So fundamentally, they are very low poly, very low poly. Those things actually, directly, many times, especially in multiplayer, they're like, dude, I shot it, and it's like, it did not register. It did register. The low poly mesh did not register it. Basically, the collision body. All those things, that's the reason why you can't destroy game worlds. And that's why, like, syncing multiplayer, this cannot be done in multiplayer. Like, and that's why whenever you have this sort of event in multiplayer, it's pre-scripted. Meaning in Battlefield, like, you are breaking the dam, it will always break the same way, because it's not real time. Or if they try to do real time, it will literally just trigger an animation that will do real time animation for that computer, and you'll like screen capture it. Like, wait a minute, this is the same map, same player doing this, and like 2-3 players are like, dude, why the heck they are different? That's why it has to be done in server end. That Stadia could have done. They're like, bro, interaction on a level that you could not have even imagined. At least like after 2009. So server can deal deal with a changing map. Meaning, for example, what happens to the bodies you see in this? Again, computers are very low power equipment. Servers are huge. Imagine like you literally seeing corpses piling up. Like, that's a big thing. Like, I specifically watched Ragnarok. They had one of the scene where, like, not Ragnarok, I think the older one, where Atreus kills a lot of elves, and there are like body piles. It's like, whoa, feels like there is an impact on the scene. Why the heck it does not happen anywhere else? Computer cannot handle it. And again, even if computer can handle it, console can't handle it. So they're like, yeah, we just magically poof it. Imagine that happen. Like, you're playing a game and the damage to the world piles up. It will literally feel impactful. Like, you can bind that into a story and be like, hey, price of war is high. You can see, hey, I destroyed this whole village. Hey, I can see corpses everywhere. It will be different. So interaction would be on a whole different level. You can free roam, you can do things. That could have been done if Stadia was designed for it. And then we come to the massive multiplayer online games. So multiplayer makes money. Why do you think PUBG is such a big deal? It makes money. Why Forza I'm saying basically, Fortnite is a big deal, it makes money. And more player you can put into one map, the more profit you're gonna make. And at this point in time, people have learned it's like, we want more. And imagine this way, server is designed to deal with that. Like, what does server do? Deal with a lot of people. Like, you can stress a game engine like Unreal, or even Far Cry, I'm saying Cry engine, to such a point where it can literally handle 500 players. You can have armies and logistics in a game real time. It's on a whole different level. Basically, instead of watching animations of this sort of thing, imagine all of them are an actual player. All of them. Like, you will have interactions. It will be completely different thing. It will be unique to a point where it's like, not everybody will like it. Let me be very clear. Not everybody will like it. But those who will like, they're like, dude, I can only get this here. And that's what you always want. And it could be like true second life scenario with better, graphics, better interaction, better capabilities. Like how EVE Online became such a big deal. But like, look at the real-time graphics of it. It's like very low end. Like, you don't have like physics simulation. Again, they could work it if every game was, rather than being in your system, it was in a server where it was being rendered there. That could have been done. So basically, Stadia had a lot of potential if they had used new tech capabilities for new technologies. Basically, like, oh, I can do this. Oh, rather than like, having like, game ported here, I just have basically a whole game decompressed in the RAM, so we do not have to worry about calls. Like, oh, I'm calling, oh, I'm loading this stage. No, everything is in the RAM. That's why, like, you port old game, like let's say IGI, you put in an SSD, latest and greatest SSD, it still takes time to loading screen. Why? It was not designed for it. So imagine, like, you port a game, it's like, bro, go YOLO, flex yourself. And one server, and you'll have as many, let's say a map has like 500 passenger slot, you'll have one server, 500 subunits that are rendering. Again, those will be virtualized. You will not actually have 500 servers virtualized, and that's it. It would be completely different. Like, it would have like different, whereas like, no, this experience can only be held in Stadia. Nobody else could come close to it. Nobody else could clone it, even if they tried it. And that would have given the fact, like, of course, it would have taken 1 generation to 2 generation to really be awesome. But again, you do not invest in a product where it's like Mark 1 is good. Mark 1 is always garbage. Mark 2, Mark 3, Mark 4, it's good. So the idea of what basically Stadia did was, in the end of the day, it was remote console. That has always low prospect. I was like, it's a good, convenience good, but it's like, if I have to deal with the consequence of latency, it really should bring something extra to the table. Again, these things I just talked about, it could have done. Like, again, I told you, like, there are many E3 demos of server running a game where game engine was like, hey, I'm not for lowest denominator, I'm for cutting edge. It would have been mind-bogglingly different. So this was my presentation on why Stadia failed, one vector of it. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.